All right, everybody. How are you doing? It's your boy, Mr. K. Yeah, don't know why I said that. In any case, we're going to go ahead and go through the first 2 pages here of your OST review packet. Hopefully, you're having a nice, relaxing time as we are just kind of dealing with our education long term here, at least from home for the time being. So in any case, I'm going to go ahead and go through the first 2 pages of answers here. Ideally, you would have gone ahead and went through the first 2 pages of questions on your own to kind of see what you recall, what you don't recall, and all of those things. Obviously, if you haven't done that yet, please pause the video, go do that, and then come back. You're going to get a lot more out of this that way. Audio quality should be okay. I'm just using my AirPods, so I don't know if it sounds good or not, but it should sound fine, I guess. So in any case, that's enough waffling. Let's go ahead and go right into the questions. First question here, number one, the movement of molecules from an area of higher concentration to an area of lower concentration is called. The answer here, of course, is diffusion. Go ahead and hit that. And that's literally the definition of diffusion, right? If you recall, we learned that a while ago. Some of the other words here, active transport, which is the answer for D. That's the wrong answer, right? But in any case, active transport is when energy is used to move stuff around any kind of system. Like think of a cell, for example. Osmosis is just diffusion of water and all of that. We're not going to really worry about the other terms so much. You might have heard endocytosis before, right? But diffusion is the correct answer. For number two, which of the following is not true of an enzyme? An enzyme, and then it kind of asks you here, and the correct answer is C. An enzyme does not necessarily provide energy to start a chemical reaction. Okay? All the other things are true. An enzyme is usually a protein. It can act as a biological catalyst, meaning it's something that can speed up a reaction, right? It is specific, meaning an enzyme causes one thing to happen, right? And it can lower energy for chemical reactions, which we haven't really talked about too much. But basically, to get any kind of chemical reaction to happen in your body requires energy. And what an enzyme can do is it can lower the amount of energy that's needed, right? So C is the correct answer here. Moving on to number three, phospholipid molecules in a membrane are arranged with their blank on the exterior and their blank on the interior, which is referring, of course, to the head and tail region of those phospholipids, if you recall that from like August, right? The answer here is B. Hydrophilic heads, hydrophobic tails. Hydrophobic means it does not like water. Hydrophilic meaning it loves water, right? So the head region really likes water, the tail region does not like water. And because of the way that phospholipid biolators tend to be oriented, remember they are a double layer, right? So all that water is pushed out from the middle of the layer, thus forming the two layers and thus forming any particular cell membrane. Moving on to number four. In osmosis, water always moves toward the blank solution, that is, toward the solution with the blank solute concentration. Answer here is B. Is B. If you recall from our osmosis stuff, water will always follow the salt, basically. Hypertonic refers to which part has the most water, right, or the highest concentration. So in this case, hypertonic solution refers to what kind of solution has the most salt in it, a high amount of salt, right? And so water will always move toward the highest amount of salts. That is the solution with the greater solute concentration. Solute is anything dissolved in the water. The water itself would be called a solution. The thing dissolved in it would be a solute. All right, number five. Let's see here. Which of the following enables a cell to pick up and concentrate a specific kind of molecule? Um, this isn't something we ever talked about in class, is it? Answer here is D, though I don't really expect you to know that. Don't worry about that one. On to number six. Oh, this is fun. A cell uses energy released by blank reactions to drive the blank reaction that makes ATP. Then it uses energy released by the hydrolysis of ATP and blank reaction to do various kinds of work in the cell. So a lot of different gaps here, and it extends all the way back to this top part up here. But a lot of different terms we could use here: exergonic, endogonic, all of that fun stuff. All of that is referring to which way heat is going. If you think about like any kind of explosion, that would be an example where heat is going out from a system, right? So that would be exogonic or exergonic rather. And if there's some sort of situation where heat is entering a system, think of I can't even think of a good example right now, but that would be an endergonic reaction. So the correct answer here is C, which is right up here. Okay. So a cell uses energy released by exergonic reactions, meaning those reactions are themselves releasing energy, thus that allows the cell to use it, right? To drive the endergonic reaction that makes ATP. To put ATP together, your body has to use energy, right? It actually has to use energy to make the currency that actually is energy for the body. Drink my tea here. Hang on 1 second. Started doing this new thing where I'm drinking more tea. In any case, then it uses the energy released by the hydrolysis of ATP and the answer exergonic reaction. Because there's just kind of a big hint here in the question. It says energy released, right? That's going to be referring, of course, to exergonic reactions. Moving on to number 7. For number 7, energy of activation. Answer here is B, is energy to get a reaction going. Should be pretty self-explanatory. To activate anything means to start it, and to get a reaction going means to start a reaction. None of the answers here are really correct. Energy of activation isn't necessarily released, so in that case, A is incorrect. C would be incorrect for that exact same reason. E is an interesting answer. Although the enzyme doesn't typically actually provide energy, the enzyme can sometimes use energy for any kind of reaction. But in any case, energy of activation, get something started. B is your answer here. All right, moving on to number A. 8. Sorry, I just gave away the answer. Yeah, it's A. But the laws of thermodynamics state that whenever energy changes occur, blank always increases. Disorder is the answer here. If you had physics or physical science and you talked about the laws of thermodynamics at some point, then you'll know that as energy continually changes the different forms, obviously you can't ever create energy, you can't destroy energy, it just always changes forms. But as that happens, you always increase the amount of disorder that is in the universe. So moving on to number 9. Living things transform kinetic energy into potential chemical energy in the blank when blank is made. Okay, so another kind of two-part thing that you fill in the gaps here. But in any case, we have to pair up the kind of the organelle for the first part with whatever molecule it's actually making. Only one of these is actually correct, okay? So if we look at, well, let me indicate the correct answer, I guess. That E is the actual correct one. But when we look at these, A says mitochondria, then ADP. ADP is the version of ATP that is actually not useful. So when ATP is used by a cell, it transforms into what's called ADP, and then it needs additional energy to be useful again. So essentially, it's kind of like recycling, but this is its unuseful form. So that's not the correct answer. Obviously, mitochondria does not make ADP, right? So that's not it. Same thing with B. A chloroplast would be the site where photosynthesis occurs in a plant. Same kind of situation. It would not be making ADP, okay? Nor would it actually be making ATP at all, which is why E is the correct answer. But if we keep going, C has a chloroplast and then an enzyme. No, that No, that's not how enzymes work. D says mitochondria with glucose. Interesting answer, but remember, glucose is actually broken down in order to release ATP from the mitochondria. That's why you have to eat food, right? So E is the actual correct one. If you recall the equation for photosynthesis, right, you have your water, your carbon dioxide, what was the other thing? Sunlight, right? All of that reacts to form water and glucose, right? So that glucose molecule is actually what's being made for the plant. So E is the correct answer here. For number 10, why does heating interfere with the activity of an enzyme? This is an interesting question, one we didn't explicitly talk about in class. Answer here is B. What can happen when you heat an enzyme? And you can do this kind of in the lab if you want. Like you could literally take enzymes and put them on a stove, right? But your body does this as well. If you think about it, like your body temperature increases when you get sick and stuff like that. Um, and what happens is, as the temperature changes for the enzyme, the shape of the enzyme actually changes, which means it can be less useful overall. Doesn't necessarily kill the enzyme, doesn't necessarily destroy the enzyme, doesn't necessarily kill the cell. I mean, let's hope not. And it doesn't really increase any amount of energy that's actually needed. But what it does do is it changes the shape of the enzyme. Uh, I guess kind of a crude example of this would be take a Lego and put it in boiling water, and eventually the Lego will start melting, right? The shape starts to change. Moving on to number 11. An enzyme is specific. This means, answer here, D. So this can be somewhat confusing. So I'll take a minute here to go over this. Um, with an enzyme being specific, what that means is that it has a specific function, as in it's used to do one specific thing. It's not that it only occurs in one type of cell. It's not that it's only found in one place. It's not that it only has a certain amino acid sequence, but rather it does one particular thing. And in this case, speeds up the particular chemical reaction that the enzyme is associated with. So there are specific enzymes that are associated with specific chemical reactions, and there aren't really situations where there's one enzyme and it can do like 6 different things, right? Not really how that works. So D is the correct answer here. And then the last one on this page, number 12, diffusion of water across a selectively permeable membrane is called, you shouldn't get this one wrong, this is B, osmosis. Okay, diffusion of water is osmosis. No mention of energy is made here, so active transport would be wrong. Something leaving a cell would be exocytosis. Passive transport, not necessarily an incorrect answer here, but it's not the most correct answer you could have. Facilitated diffusion, also not correct here. Okay. And then if we go on to the applying your knowledge section, I don't know if I want to do all of these in a row. Yeah, we might want to do all the way through number 12 here, just so we kind of wrap up the whole kind of chunk of questions here, so that like the next video doesn't start halfway through the next one. But in any case, moving on to the applying your knowledge section, this should be page 2 of your little thing. And let me actually see if that's what it is. Yeah, it should be page 2 of your little thing here. So if a cell is like a factory, it's number 1. If a cell is like a factory, then enzymes are like, and the answer here is B, the machines in the factory. As in, the enzymes are the things actually doing the stuff. Okay, the power plant for the factory is referring to like a mitochondria. The walls of the factory could be referring to a cell membrane or a cell wall, depending on what kind of cell we're talking about. Raw materials used by the factory could really be like amino acids. Plans for the factory could be like the DNA, right? Moving on to number 2. Again, some of the answers are up here. A molecule that has the same shape as the substrate of an enzyme would tend to, and the answer is E all the way over here, slow metabolism by blocking the enzyme's active site. So another confusing thing that we haven't talked about too much in class, the way enzymes work, remember they are specific, right? So they do specific things for cells, so they bind to specific locations, right? So if there's something else that binds to the same exact location as an enzyme, as in it has the same shape, what it's going to do is it's going to slow down how effective that enzyme can actually be because there's something blocking it, right? There's something that could potentially take the same spot an enzyme would want to take. So in that case, it would slow down metabolism. Metabolism being the sum total of all the chemical reactions happening in your body. So when people say, oh yeah, you must have a fast metabolism, what that is referring to is that your body's able to break stuff down quickly. Okay? All right. 3 is a throwback to more osmosis stuff here. So a plant cell is placed in a solution whose solute concentration is twice as great as the concentration of the cell cytoplasm. The cell membrane is selectively permeable, allowing water but not solutes to pass through. What will happen to the cell? Answer here. What is the answer here? I think B is the answer here, right? Cell will shrivel because of osmosis. So the way we get to that answer, if you look at the question, the cell is placed and the solute concentration is twice as great as the concentration in the cell, meaning there's more salt outside. Okay. Hang on, is this correct? Plant cell is placed in a solution whose solute concentration is twice as great as concentration of the cell's cytoplasm. Yeah, that is correct, because water will leave the cell. It's more salty on the outside. Yes, so the cell will shrivel because of osmosis. I had to kind of confuse myself, I guess. So that's the answer here. C is indicating the reverse of it. The cell would swell up. If there was more salt inside the cell membrane, that means water would follow the salt, as we discussed previously. And oh, go away. And yeah, so in that case, it would absorb more water. Active transport wouldn't occur here, so we don't have to worry about D and E. And A is incorrect as well. Just because it's a plant cell doesn't mean that nothing would actually go through the cell membrane, in this case, the cell wall. It still can. So B is the correct answer. For number 4, a white blood cell is capable of producing and releasing thousands of antibody molecules every second. Antibodies are large, complex protein molecules. How would you expect them to leave a cell? So, antibodies are part of your immune system, and so they're relatively big things. So, relatively big things cannot just diffuse through a cell membrane the way water can. That's restricted to relatively small molecules. Larger molecules can leave through active transport, for example, but that's not the correct answer here. Even antibodies might be a little too big for anti-transport. The correct answer here is exocytosis, which is where the antibody or whatever molecule is leaving the cell literally goes up to the cell wall, and then the chunk of the cell is just ripped off, basically. None of the other answers here are really appropriate. For number 5, which of the following would be least likely to diffuse through a cell membrane without the help of a transport protein? Okay. The correct answer here is A. Remember, with the cell membrane, there are two different layers of it, right? There's a layer that really likes water and a layer that doesn't like water. This is referring to polarity, right? So not a word that we use often in biology, unless you happen to be in chemistry right now, then you're probably more familiar with this term. But a large polar molecule would have a hard time actually diffusing because water well, the fact that it's polar would make it more difficult to go through the actual cell membrane. We can do a more detailed explanation on polarity probably when we get back or in a separate video entirely, because that's somewhat of a tricky concept, and I don't want to make this video too long by diving into the specific question. So we'll just kind of move forward here. But a large polar molecule would have a more difficult time than smaller molecules or a large nonpolar molecule. Okay. So for number 6, red blood cells shrivel when placed in 10% sucrose solution. When first placed in the solution, the solute concentration of the cells is blank the concentration of the sucrose solution. When the cells shrivel, their solute concentration is blank the concentration of the sucrose solution. So another interesting question where I have to fill in some blanks. Given that what happens here? The cell initially what? Shrivels, right? Yes. Looks like that's what happens here. The answer here is D. So, when first placed in the solution, the solid concentration of the cells is less than the concentration of the sucrose solution. As in, the red blood cells don't have higher than 10% sucrose solution, right? They probably have under 1% of that. But if they're placed specifically in the solution, they have less than that, and water will follow the solute, in this case the sucrose, so water will be drawn out, which would be exactly why the question says that the cells shrivel. So there's after the cells shrivel, the solute concentration is then equal to that of the solution. That's the whole point here, right? You want equal concentration of whatever kind of solute we're talking about inside the cell and outside the cell. Right? You want 50% inside the cell, 50% outside the cell. In a situation where that's described here, at least, where the cell has way less than what's on the outside, because there's more solute on the outside and water will follow the solute, water leaves the cell, in this case causing it to shrivel up, and when that actually happens, now there's an equal amount of solute concentration. And then moving on to the last bit of questions here. So this is page 3 of your packet. Probably should have done a better job labeling these things. So let me go ahead and do that now. This is page 1. This is page 2. And then here we are with page 3. All right, last bit of questions. A nursing infant is able to obtain disease-fighting antibodies, which are large protein molecules from its mother's milk. These molecules probably enter the cells lining the baby's digestive tract via, then it asks exactly what kind of mechanism it's referring to. And in this case, it's referring to endocytosis. So think basically the last question about the antibodies, kind of a similar situation. In number 4, which is the one right here, right, where we talked about the antibodies being too large to really do diffusion. Same kind of situation here, but it's actually the exact opposite question, where instead of the cells need to go out to fight disease, right? In this case, the antibodies need to go in to help the baby be more immune to different diseases. So that reverse process is called endocytosis. And basically what happens for the antibodies to actually enter the cells would be the antibody goes right up to the cell membrane, and then basically part of the cell membrane grows around it to kind of cover it, and in that way the cell kind of absorbs whatever it is that's on the outside. For number 8, some enzymes involved in the hydrolysis of ATP, cannot function without the help of sodium ions. Sodium in this case functions as a cofactor, something that's helping a chemical reaction. Okay? So I don't really know if that makes sense as far as what we've talked about in class. But for enzymes to be functional, of course, they do some specific role in your body. Sometimes they need something else to help them be functional. In this case, sodium is used for enzymes to help break down the ATP, right? So that would be called a cofactor. For number 9, The relationship between an enzyme's active site and its substrate is most like which of the following? A glove and a hand is the correct answer. An enzyme's active site is part of the enzyme that's actually going to do something, and the substrate is the thing the enzyme will bind to cause some other thing to happen in your body. Yeah. So it's very similar to a glove and a hand. You know how if you have gloves, right, your hands fit inside them pretty perfectly, right? That's kind of the situation here. For number 10, in which of the following do both examples illustrate kinetic energy? Okay, so kinetic energy, if you don't recall from physical science, or if you're in physics, perhaps you learned about this, possibly even in chemistry you learned about this. But kinetic energy is energy that's in motion, energy that's actually being used. So for example, in option A here, a ball rolling down a hill is indeed an example of kinetic energy. Heat is also an example of kinetic energy. Positions of electrons in an atom is not. Rather, that's called potential energy. Um, so it could potentially be useful for energy, but in this particular situation, it's not. So A's out. Same thing with B because it's referring to arrangement of atoms in a molecule. A rock resting on the edge of a cliff, which is for C, also is potential energy. Heat is, of course, a correct answer. That is actually kinetic energy. A ball rolling down a hill is kinetic energy. Same thing with heat. So C must be our correct answer, right? And then moving on to the last one, E, light is an example. It is an example of kinetic energy. Arrangement of atoms is not. So D is the correct answer here. Last two. Which of the following is the difference between active transport and facilitated diffusion? Oh, this is actually a pretty easy one. The correct answer here looks like E, where active transport requires energy from ATP. True, because it's active, requiring energy. Facilitated diffusion does not. True. All the other ones do not say that, right? So there you go. And then finally, the last one here, for number 12, an enzyme and a membrane receptor molecule are similar in that they bind to molecules of a particular shape. Okay? They don't supply energy. They don't necessarily require ATP. Some do. Not always attached to membranes. They don't always act as catalysts. Enzymes do a lot more than that, right? But they do bind to molecules that have a particular shape. That's referring to the specificity of an enzyme that we've already alluded to a bunch of different times here. So in any case, those are the first 3 pages of fun for your biology OST packet. So there you go. I'll send this to you in an email shortly, and yeah, there's that. So okay, happy studies. Hopefully that makes sense. If you have any questions, of course, you can email me, or you can also hit up my Twitch and all that stuff. It'll be included in the email. Thanks, guys.